Welcome to the hydraulic loading to a trickling filter math problem. We did our trickling filter big video last week, and I'm starting to follow up with some of the math that can kind of complement that video. There are three major math problems you need to know about for trickling filters. Two of them you're going to be asked about most likely on your lower level. This is one of those two. And on your higher level, there's a third. So this is hydraulic loading to a trickling filter is one, organic loading to a trickling filter is two, and then recirculation ratio is three. And it's not so straightforward, okay? So when you get into your higher level math, they're gonna do stuff like where you've got storm flows coming in and your peak dry weather flow, and you've got a maximum hydraulic loading rate, and what should your recirculation ratio be if, they kind of couch it like that, so you gotta be able to understand hydraulic loading first so that you can start figuring out your recirculation ratio and what your pump GPM should be set at. They gotta go to that level. Anyway, I don't want to confuse everybody too much. I'm just gonna start breaking this problem down, and per a viewer's request, they asked that on these lower level math problems I write it out, and I think that's a good idea for some of you who've not sat through an exam. I'm gonna show you some smoke screens that they'll put in the paragraph, the little blurb they give you. When you get to the grade 3 and higher, what they end up doing is they'll give you a little blurb for your math problem, but then it's like they'll ask you to solve for something, and they'll give you like a list of stuff. Like you've seen my earlier math problems, I just kind of list out stuff. That's how they start presenting math problems on the higher level exams. A lot of them, not every one of them, but a lot of them, because it's just so much information. And smoke screens are still in the list. They'll list stuff that you don't need. Okay, so let's break this down real quick. You have two 70-foot diameter trickling filters, 8 feet deep. The plant flow is 2 mgd, and your recirculation ratio is 1:1. What is your hydraulic loading rate? So your hydraulic loading rate is expressed in gallons per day per square foot. So that's a good place to start. We need to know our gallons per day per square foot. So first and foremost, I'm going to pull out the information I need. 70-foot diameter trickling filter. Okay, I need 70 foot, so I put that there. I have two 70-foot diameter trickling filters. So I'm going to multiply by 2. I'm going to say I've got 2 of these. And how I like to do that math is find my square foot first and then multiply by 2. I don't like to add the 2 diameters together, and it's just not my style. 8 feet deep. Do I need 8 feet deep? Nope. That's cubic feet. That's irrelevant. They'll do that to you too. So they'll give you stuff you don't need. And by the way, if you did solve this, they're going to give you a couple wrong answers. One of them is going to be that you only have one 70-foot diameter trickling filter, because they're going to assume you blew right past that word 2. And the other one they're going to do is they're going to do cubic feet. They're going to assume you've factored that 8 into there, okay? So be ready for this stuff. 70 foot is all we need. The plant flow is 2 mgd, okay? I got my gallons per day, right? Well, recirculation ratio is 1:1. That's important, okay? Because when you do hydraulic loading, you include the recirculation flow. When you do organic loading, you do not. And we'll talk about that on organic loading. I'll explain a little bit more of that. But this is all the water that's passing over the deck of the trickling filter every day. Okay, all of the water, including recirculation. So Q plus QR, my recirculation ratio is 1:1. So if my plant flow is 2 mgd, so is my recirculation. If this was 0.5 to 1, it would be 1 mgd. If this was 3 to 1, my recirculation would be 6 mgd. Okay? If you have any questions about that, please put it in the comments below. I made it pretty easy. So for every 1 gallon of water, I get 1 gallon of recirculation. Okay, that's what a 1:1 is. So for every 2 million gallons a day of flow into my plant going over my trickling filter, I've got 2 million gallons a day recirculating. That is a 1:1. Okay, so let's start by doing our square feet. So 0.785 diameter squared, which is 70. 70 foot times 70 foot is squared times 0.785 gives us 3,846.5 square feet times 2, because we have 2 trickling filters, and that is 7,693 square feet. Okay? And then we take our plant flow, which is 2 mgd plus 2 mgd equals 4 mgd. And I just did this for, the sake of it. I converted the units. You don't have to, I don't do this when I'm doing my math. I'm doing it for your sake. 4 mgd is 4 million gallons per day, because you just multiply 4 times a million. And then 4 million gallons per day divided by 7,693 square feet equals 520 gallons per day per square foot. That is a hydraulic loading rate math problem. Very simple, not hard. The organic loading rate's a little harder because you got a pounds formula and you got cubic feet. This is as basic as it gets. Now, something they might do to you is they might, instead of giving you MGD, they might say that you've got 20 gallons, or I don't know what that is in gallons per minute, 1,000 gallons a minute. And you got to figure out how many it is, gallons per day, and do a little bit of math. But this is probably about as easy as it gets, like I said. Okay, any questions at all, please put it in the comments below. If you got anything out of this, please like, subscribe, pass to your friends. Let's help folks get certified. And if you have a variation of this that you ran into on your test, please put it in the comments. Let's help people out. Take it easy, everybody.